All right, this is the fifth FRQ from the 2018 AB exam. And I apologize in advance. The kitten that I got yesterday is very screechy right now because he likes attention, and you'll probably be able to hear it in the background. Sorry. All right, so part A says to find the average rate of change of f on the interval. And so we just need to do f of pi minus f of 0 divided by pi minus 0. And so f of pi is e to the pi cos pi. F of 0 is e to the 0 cos 0. And then before I simplify more, you can see that this is already written in because I started the video and then I didn't get the math right because the kitten was distracting me so much. Okay, here's my unit circle. Goodness gracious. Okay, so if I have cos of pi, that's -1, and so this is e to the pi times -1, which is negative e to the pi. E to the 0 is 1. Cos of 0 is 1, so that's -1 over pi. So there's the average rate of change, which is just slope. Part B asks you to find the slope of the tangent line of the graph at 3 pi halves, and so that means that for this one we're going to find the derivative and evaluate it at 3 pi halves. So the original function is e to the x cos x. This requires a product rule. So I'm going to say that the derivative is the first times the derivative of the second plus the second times the derivative of the first. And then I'll go ahead and plug in 3 pi halves. So sine of 3 pi halves is -1. So I have negative e to the 3 pi halves times -1, that's just e to the 3 pi halves. And then cos of 3 pi halves is just 0. Oh, sorry about it, Broom just fell on the kitten. He was fine, he got out of the way, but that's how life goes. All right, so that's 0, anything times 0, so it's just this. So the slope of the tangent line is e to the 3 pi halves. All right, so part C asks you to find the absolute minimum value on the interval from 0 to 2 pi. So we're going to use the endpoints, and then we're also going to look at the graph of the derivative to see if there's any relative minimums. And so relative minimums are going to happen where the derivative switches from negative to positive, because that would be g of x switching from decreasing to increasing. And so we're also going to consider this part of the graph right here. So if that's pi halves, then that would be pi fourths. So I'm going to consider 0, pi fourths, and 2 pi. All right, so f of 0 is e to the 0 cos 0. And cos 0 is 1, so that's 1 times 1 is 1. Sorry guys, I just realized I was looking at this for part C, and that's not for the entire problem, that's only for part D. Some of these actually end up being good. I'm going to leave this work for a second, and we're going to come back to it. So I would remake the video, but I'm not remaking it for the third time. So what I actually did when I did it before I was making the video, and not what I did just now when I was distracted by the cat, is I took the derivative and I set it equal to 0. So this is just saying, yeah, because this is f of x and the graph was g of x. Anyway, take the derivative, set it equal to 0. We're going to look for the places where it equals 0. Those are your critical values. And then once we know what those critical values are, we can test them and use the extreme value theorem. So the derivative was negative e to the x sine x plus e to the x cos x. And so what I did is I factored that. And then since it's in factored form, you can set them both equal to 0. So e to the x equals 0, negative sine x plus cos x equals 0. There is nothing you could plug in for x that would make this 0 out, so this is not going to give you any solutions. And then over here we have cos x equals sine x. So I have to picture the unit circle and think about where on the unit circle the x-coordinate and the y-coordinate are exactly the same. And that happens in two places. It happens at pi fourths and 5 pi fourths. So if you picture the unit circle, at pi fourths, it's root 2 over 2, root 2 over 2. And at 5 pi fourths, it's negative root 2 over 2, negative root 2 over 2. So those are the two places where the x and the y coordinate are identical. Okay, so that means that we just have to consider some more values here. This is why I stopped, because I knew that I didn't have the right answer on the table. Okay, so f of 0 is 1. F of pi fourths, we've got e to the pi fourths times cos of pi fourths. Cos of pi fourths is root 2 over 2. Okay, so that's root 2 over 2, e to the pi fourths. Then we have f of 5 pi fourths. Cos of 5 pi fourths is negative root 2 over 2. So we've got negative root 2 over 2, e to the 5 pi fourths. And then f of 2 pi is e to the 2 pi cos of 2 pi. Cos of 2 pi is the same as cos of 0, it's just 1, so that's e to the 2 pi. So if we're looking for the absolute minimum value, there's only one answer that's negative, and it's this one. So the absolute minimum value is negative root 2 over 2 e to the 5 pi fourths. Oh my gosh. Okay, and then part D. So part D says to let g be differentiable such that g of pi halves is 0, and then they give you the graph of g prime, and they want you to find the value of the limit. So I'm going to say the limit as x goes to pi halves of f of x over g of x. And I don't know if you felt the same way I did, but I looked at this and I was like, oh, it's probably L'Hopital's. And since I knew that, I went ahead and I just went straight into the correct notation for L'Hopital's. So I said, okay, I'm going to do the limit as x goes to pi halves of f of x. And the limit as x goes to pi halves of f of x would just be e to the pi halves cos of pi halves. And then cos of pi halves is 0, and so that gives you 0 there. And then the limit as x goes to pi halves of g of x, and they gave this to you. They gave this to you on the front. G of pi halves is 0. So that equals 0 as well. And since they both equal 0, you have 0 divided by 0, which means we're going to use L'Hopital's. Okay, so now I'm going to have the limit as x goes to pi halves, f prime of x over g prime of x. So f prime of x is going to be negative e to the pi halves sine of pi halves plus e to the pi halves cos of pi halves. So I'm just using the derivative, which I have written up here for part C. And then g prime of pi halves. Here's g prime of pi halves is 2, so that's the reason they gave you that graph. Divided by 2. And then sine of pi halves is 1. Cos of pi halves is 0, so that zeroes out that whole thing. So we end up getting negative e to the pi halves over 2.